Welcome to the 240M Module 7 lecture. We're going to talk about several different objectives. First one's going to be performance monitoring and tuning, then processor scheduling options, virtual memory, task manager, event viewer to look at Windows logs and application and service logs, event log management, event log meanings, the different types of event logs, performance baselines, performance monitor, bottlenecks, counter alerts, and the reliability and performance monitor console. Performance monitoring and tuning, the process of tracking system performance to establish baselines and to identify and resolve problems. When you install a server, you should create a performance baseline to see how the server is performing given its current resources and typical usage. So what this means is that when you first install a server, you should do a performance baseline. So later on down the road, you can compare that to how the server is performing to see if there's any significant difference, either one way or the other. Processor scheduling options controls how much processor resources are allocated to applications running on a server. You can optimize processor scheduling for the following application types: programs and background services. Programs would be if you had any type of programs installed for a remote desktop services server, whereas background services would be pretty much anything else that the server would need to run in the background, such as the operating system, Exchange, Microsoft SQL, that kind of thing. So programs, the active foreground application running on the system, gets the best response time and the greatest share of available resources. Background services are where all applications receive equal amounts of processor resources and the active application doesn't get the best response time. So let's take a look at that. All right, so under the Advanced tab on System Properties, we're going to go ahead and click on Performance. And we'll click on the Advanced tab again, and you'll see this option, which by default is set to background services. So if you want every single application and service all running with the same amount of resources, then you would choose the default background. If you want to have the programs that are installed to have better response time, then choose Programs. When done with whatever you want, you can just click Apply. Virtual memory. This is used to allow a system to write parts of memory to disk. All servers have an initial paging file. It is created automatically on the drive containing the operating system, usually the C drive, during installation and setup. The file name is pagefile.sys. The book, in most cases, recommends 1.5 times the amount of RAM, but we recommend that you double the amount of RAM. Although Windows Server 2012 can expand paging files incrementally as needed, you'll want to size the paging file so that it is as large as it needs to be for average usage conditions. If a server has multiple hard disk drives, you might consider creating a paging file for each physical hard disk drive on the system. So let's take a look at virtual memory. So under the Advanced tab, where we just were for setting the processor scheduling, you'll see where it says virtual memory. So you'll see the total paging file for all drives is 384 megabytes. Now, by default in 2012, it's going to automatically manage the paging files for all drives. Now, in this case, we only have the one drive. But if we wanted to, we could uncheck that, and we could say system managed just for the C drive. If you had multiple drives here, you could have one be system managed and have another be a custom size. Or we can just choose custom size right here. So let's choose no less than, say, 200 megabytes. And then let's see how much RAM we have in the task manager. We have 2 gigabytes of RAM. So let's make the maximum 4,000 megabytes, which is 4 gigabytes. Now if we click OK and we go back in, you'll see that didn't stick. So what you have to do is click Set. Then click OK. Otherwise, it won't save it. So now you can see it's saved it. You can also say to not have a paging file. Of course, you have to have at least one computer with a paging file, or one drive with a paging file. Otherwise, the computer will not perform properly. So we'll go ahead and change this back to automatically manage for all drives. Usually this is fine the way this is set up. Sometimes you'll have an application that requires that you set this manually. Now, what is a paging file? So a paging file, basically, when you run out of RAM, it uses part of the hard drive as RAM. So if we go into our computer, C drive, you don't see the paging file. So what you've got to do is you've got to open up to be able to see the hidden items. Then you go in and you uncheck the box that says Hide Protected Items. Click OK. All right, now we see our paging file, and this is the file that's going to be used when we run out of RAM. Task Manager, the fastest, easiest way to track a system's general health. You can track running applications and processes and determine resource usage. Task Manager has 5 tabs. I just used Task Manager to see how much RAM we had in it. It has the Processes tab, which lists the image name of the processes running on the system, including those run by the operating system and users. It has the Services tab, which shows the system services configured on the server. It has a Users tab, which details the users currently logged onto the system. It includes local and remote desktop sessions. It also has a Performance tab, which is the most common one. It displays current processor, network usage, and memory usage. And it has a Details tab, which displays the executable files running that make the programs running work. Task Manager uses resources while it's running, so because of this, you should run it only when you are trying to track performance. If you leave it on all the time, it will unnecessarily use up processing and RAM. The Performance tab should be the first tab you check if you suspect a performance issue with the system. It shows the current processor, networking, and memory usage, and also graphs some historical usage statistics based on data collected since you started Task Manager. So let's take a look at the Task Manager. So from the bottom bar, we'll click on Task Manager, and we'll see the 5 tabs. Now, in older versions of Windows, you'll see a 6th tab for Network, but that's now incorporated into the Performance tab. So under Processes, we see all the different processes that are running on the server. Click on Performance. You can see CPU usage. You can see memory. And you can see Ethernet, how much network traffic. Now, since we're not connected to the network, you're not going to see any Ethernet traffic. Users, it shows that only the administrator is currently logged in, and the 11 applications that the administrator is currently running. It also shows how much CPU and memory. You can also right-click at the top, and you can add in additional columns, such as you will in the lab. Under Details, you have all the executable files that make all the processes on the first tab run. And then under Services, you have all the services that make the executables and processes run. So if you're in a process and you want to see what details, executables, and what services are tied to this, just go ahead and right-click on any one of these, and we'll choose Go to Details. And watch this, it'll jump us to the Details tab. And it shows us that Explorer.exe is what runs Windows Explorer. Now if we right-click on Explorer.exe, we can also go in and see if it's going to a particular service. And we can see that no services are highlighted, so there is no service tied to Windows Explorer. But there may be other ones that do have services. Let's go, for instance, to SQL Server. Go to Services, and we see MS SQL. So that's the 5 different tabs and how they're used. Event Viewer. Event Viewer in Windows, it defines an event as anything significant, any significant occurrence in the operating system or an application that should be recorded for tracking purposes. The different types of messages are informational, warning, error, critical, success audit, and failure audit. There are multiple categories of log files. There's Windows logs that logs the operating system, uses to record general system events related to applications, security setup, and system components. Applications and services logs, logs that specific applications and services use to record application-specific or service-specific events. Application logs contain events logged by applications. So if you look at the application event log viewer, you're going to see all different things that tie back to applications that are installed on the server. They could be services that are role services that you installed, or they could be third-party applications. And there's a default log size to that event log. Forwarded events, when you configure event forwarding, this log records forwarded events from other servers. The default log size again is 20 megabytes. There's also a setup log, which records events logged by the operating system during the setup and installation. Security logs contain events you've set for auditing with local or global group policies. By default, it will only log user log on and log off unless you add additional audited events. It's a much larger default log size at 131 megabytes on domain controllers and 20 megs on member servers. Only administrators are granted access to the security log by default. System logs that contains events logged by Windows Server 2012 and its components. You should routinely check this log for warnings and errors, especially those related to the failure of a service to start at boot up or the improper configuration of a service. The default log size is 20 megabytes. System is the one that shows most of the information that is useful about the operating system and hardware itself. That's the one I usually go to first, followed by the application log. DFS replication. If you're using DFS, such as we are in our labs, then you'll see a log for DFS. If it's not installed, you won't see it. This log records distributed file system replication activities. Directory services contain events logged by Active Directories. You can see if Active Directory is having any failures. DNS, again, you only see this if you're running DNS, contains DNS queries, responses, and other DNS activities. And the file replication service is only on domain controllers that shows replication between Active Directory. You can also look at hardware events when hardware subsystem event reporting is configured. This isn't always configured by default. This log records hardware events reported to the operating system. Windows Server 2012 logs are configured to overwrite old events as needed. When the log reaches its maximum size, it overwrites the old events. You can have Windows automatically archive logs so that they are not lost. You can also configure logs so that Windows never overwrites events. You don't want to do this because it may fill up your entire hard drive and cause the server to crash. We talked about different types of events. The first one is informational. Generally relates to a successful action such as the success of a service starting up. A warning log describes events that aren't critical but could be useful in preventing future system problems. Critical logs they demand immediate attention or imminent failure of the server will occur. Error logs indicate a fatal error or significant problem such as the failure of a service to start. And under the security logs, you'll see an audit success or audit failure for when people log on to the server, whether they were successful or not. Archiving event logs allows an admin to save several months of log data, and I'll show you how to do that. Using subscriptions and forwarded events can forward specific events to a central event logging server. So if you don't want to add the events individually on each server, you can have them all forward to one server, and then that server can then show you the logs all at once. So let's take a look at the log server, event logging. We can get there multiple different ways. One way is through Server Manager, just like a lot of other tools we'll see under Server Manager. Wait till everything logs up, and then go to Event Viewer. Here's the Windows logs we talked about: Application, Security, Setup, System, and Forwarded Events. And then under Application and Services, you can see individual applications, whereas the application log here shows all the different applications. So you see the information type of event logs. These are ones where nothing is seriously wrong. It just tells you about certain things that started and stopped and that kind of thing. If you want, you can click on the level and you can have it go to categorize the different ones. By default, it does it by date. Here's an error log. You can see that there's a synchronization issue. Here's a warning log. No client computers ever contacted the server. That means our Windows 8 computer has yet to communicate with the server. So we may see some additional ones like that. We can also click on details, and there'll be some details about where it is in the memory that this showed up. You can also click on the XML view, which gives us another type of detail. Under Systems, same kind of thing. Under Security, here's the audit success log on or log off. Here's our DFS, our DNS server, all those different types of logs as well. Now, if we right-click on a particular log, we can open a saved log, something that we might have saved earlier. We can create a custom view where we can only show specific types of logs, so you don't have to go through all the ones that you don't care about. And now we just see the warnings and the errors. We can also right-click and go to Clear Log, so it'll flush all the logs, so it'll be back to empty, but that makes it difficult to troubleshoot if you do that, but you only do that if you think that there might be a corruption in the log itself. If you go to Properties, and from here you can change the default override events as needed, archive the log when full, or do not override events we talked about, something you should not do. You can also change the maximum log size, and if you want, you can set up subscriptions to other computers so they can send their system event logs to you as well. Under forwarded events, this is a more comprehensive way of forwarding events to you from other servers, where it can send all the different logs to you. Performance baselines allows you to compare past performance with current performance. There are different types of baselines. You can also do a post-installation baseline, a performance level that is meant to represent the way a computer performs just after installing all the roles, role services, features, and applications that will be used on the system. So you can do it before the installation of different roles, and you can do it afterwards. Typical usage baselines, a performance level that is meant to represent average usage conditions and serve as a starting point against which you can measure future performance. You would do this by having everyone log in just after it's installed and use that as a typical usage baseline. Test baselines is a performance level that you use during testing of a system. You should also collect several data samples at the same time each day over a period of several days. You must work to keep the baseline in sync with how the server is used. As you install new roles, role services, and features, you're going to want to do a new baseline. Performance objects represent any system component that has a set of measurable properties. A performance object can be a physical part of the operating system, a logical component, or a software component. Performance counters represent measurable properties of performance objects. For example, the percent of processor utilization. In a standard installation of Windows Server 2012, many performance objects are available for monitoring. As you add services, applications, and components, additional performance objects can become available. For example, the DNS object becomes available for monitoring when the DNS role is installed. A bottleneck is any condition that keeps a computer from performing at its best. For example, if a system doesn't have enough physical memory, it doesn't matter whether it has a fast processor or a slow processor. It will run slowly because it doesn't have enough RAM. And that's what you use Performance Monitor for. You need to find out what is the bottleneck. You can configure alerts to notify you when certain events occur or when certain performance thresholds are reached, and we will do that for our lab. You can send alerts as network messages and as events logged in the application event log. You can also configure alerts to start applications and performance logs. So let's take a look at the Performance Monitor. In our Server Manager, we can just go ahead and click on Tools and then click on Performance Monitor and then click on Performance Monitor. By default, you're going to see the percent processor time, which is just how much of the processor, what percentage of the processor is being used, and you're going to see that float up and down. You can also click on the highlight button. It highlights that in case you have a lot of counters, or it sort of highlights a particular counter you're interested in. You can also add counters by clicking on the plus. And we'll just go ahead and choose a particular one. Let's choose memory. And let's choose cached bytes. Let's go ahead and click add, click OK. And now we can see a second monitor that shows up at the bottom for cache bytes. From here we can go ahead and click on properties, and we can change the color so it's a contrasting color. You can also change the width, and you can change the scale. Scale is helpful in case it either shows up at the bottom or at the top and you're trying to actually see something else. Let's go ahead and add another one. And this time we will choose TCP/IP4. And we'll say connections active. Go ahead and add that. Click OK. And then again, we'll go in and change it so it's a color that we can see a little better. There we are. And we'll go ahead and ping. And we'll do a -T so it does a continual ping. Sometimes you have to play with the scale to get it to show up the way you want it. There we go. Finally got the scale that works for us. So we can see that line going across the screen. Alright, so there is your performance monitor. You've also got data collection sets. You can have user-defined collection sets. You can choose new data collector set, and you can pick specific template ones, or you can do a specific one that you have created in a file. You can also do a custom one as well. So we talked about performance monitoring and tuning, processor scheduling options, virtual memory, task manager, the different types of event viewer logs, and we went into performance monitor to look to see how we can use that to find bottlenecks.